Dear students, in this lecture we are going to discuss armature reaction in synchronous generator. To understand this, let us take a simple example of two-pole machine, obviously cylindrical rotor machine. As for salient pole rotor, we need to have minimum number of poles as 4. So for two pole, obviously our rotor will be cylindrical rotor, non-salient pole rotor. As we have discussed in our previous lectures that in cylindrical rotor, field windings are distributed in various slots. So you know what is dot and cross notation. This will create two poles, field poles, north and south as shown. Once this rotor is being rotated, what will happen to the armature conductors on the stator? Stator winding is having three phases. Let us mark the phases. This is phase A, let us mark as phase B and phase C. 120-degree electrical apart in a space C, A, then 120-degree, after that B, then 120-degree C. The other ends of the coils, for A we may mark A dash, for B other end diagonally opposite, right, diametrically opposite B dash, and for C, C dash. Normally stator windings are distributed, but for sake of simplicity we have shown in a single slot to make the concept easier, concept of armature reaction. So let us first find out the polarity in all coil sides. So let us take coil side A. Suppose this rotor is being rotated in anti-clockwise direction. Mark here this omega s. We may rotate either clockwise or anti-clockwise. Let us take any one, right? So once the rotation of this rotor is anti-clockwise direction, it means if you are sitting on the rotor, then relative motion of this conductor in this slot, let us say A, with respect to this field will be opposite to that. See, stator is stationary part, rotor is rotating part, and rotor is rotating in anti-clockwise direction. It means the relative motion of conductor at a stator with respect to rotor or rotor field will be clockwise. Hope it is clear to you. So what will be induced EMF? See, for getting polarity of induced EMF in any conductor, we need F, B, I. F is force or direction of motion, B is magnetic field, and I is current. If load is connected, then current will flow as per the polarity of induced EMF. Fine. So what is direction of field? Upward. We can see S is here, N is here, as dots are shown here, right? So upward. So field is upward, FB, B is upward, and force on the conductor means motion of the conductor. In simple way, we can check motion of the conductor. So motion of the conductor is basically, a conductor is stationary, but motion with respect to field basically, right? So if field is rotating anti-clockwise, so motion of conductor with respect to field will be clockwise. So F is like this and B is upward, field, motion of conductor with respect to field is clockwise and this way. So this is out of the plane, that is dot will be denoted here, right? This is a polarity. Similarly, we can get the direction in others. Before that, suppose load is connected. So once EMF will be induced here, and here what will be that? Cross. Here it will be cross with the help of FBI. So now F is this, B is upward, so I is downward, cross, right? Force is force, clockwise here will be this. thumb will indicate this way, fine. So cross will be there. So if load is connected, then current will start flowing having this direction. If load is not connected, even though EMF is induced, load current will be 0, all the 3 phase currents will be 0. So once load current, armature current will flow, it means corresponding field flux will be there. So what will be axis of those flux? So for this coil, what will be axis? So let us take dot as positive polarity and cross as negative polarity throughout. Means in case of current out of the plane as positive and into the plane as negative. This will be our convention throughout the lecture. So the corresponding flux will be having this direction. See, for field, these dots corresponding to these dots and cross, we have this direction of flux. So come to the armature fluxes corresponding to armature current. So direction will be dot here this way. If we want to draw axis, so means axis of fluxes of currents in phase A will be like this. Means if current is 0, flux will be 0. If current is maximum, flux will be maximum. If current is minimum, flux will be minimum. So we may mark here this as phi A, or here we may mark minus phi A. So phi A and the negative of phi A, so it will oscillate between some maximum and minimum value. Suppose phi m is maximum and minus phi m is minimum. So when it will attain maximum value of armature flux in phase A, when current in this is maximum. When current will be maximum, when EMF induced will be maximum, fine. Similarly, what will be the axis of B? So B, similar to that A dash, this will be positive, B will be positive. So once dot will be there, cross will be there, then axis will be this way, right? So we will mark this is positive. Let us mark by solid lines phi B, direction of flux in B phase, right? Axis. What about C? So C dash, one dot will be there, so C will be downward, right? Phi C, and here it will be minus phi C, not showing but minus phi C. Let us show only positive values, opposite will be negative of that. So phi A will be here, minus phi A will be here, phi B will be here, minus phi B will be here, and phi C will be here, minus phi C will be there, right? So we have just marked the axis of fluxes corresponding to the alignment of the stator coils, 3-phase coils. So for coil A, see, this is vertical, so perpendicular axis will be this way. Now for B, this is aligned like this, so perpendicular of that will be this B. This is C, aligned this way, so perpendicular to that will be this way. So that's why, as per the alignment of the slots on the stator corresponding to 3-phase windings, stator windings, we have marked the axis of the fluxes produced due to 3-phase currents. Fine. Now come to this alignment. The moment when rotor is aligned this way, see, we have shown the rotor rotating at synchronous speed. So we are talking about a moment at which alignment of the rotor is like this. So this time flux linkage to the coil A will be maximum. You can observe here, right? Maximum flux density we have discussed during construction also, though a step, but maximum flux density is linked at this moment. Suppose, let us take, present case is this N S, and this is A, and this is A dash. So here we have seen that as this is being rotated this way, so dot and cross is there. So at this moment, and let us take another moment, when N was here, S was here, right? So what will be the EMF induced here? A dash. 0, because no flux is being linked in this coil at this moment. Once it is rotated and attained this position, it means maximum flux is linked with these conductors. And again, let us take some more case. So after this will be, let us take case 1. This is case 1 basically, this is 2, and now take 3, because it will start from 1, then rotate and attain this position 2, then attain next 3. So here also we can see that A dash, this is having 0, right? And let us take 4th case, when rotor is having S here, N here, 4th case. So this will be cross and this will be dot as discussed earlier. So starting from case 1, this is the moment. So at that time no flux linkage to this coil, so EMF induced is 0. After 90 degree, right, this is rotated by 90 degree, so flux linkage is maximum. Then again after rotation of 90 degree, flux linkage to this coil is 0. Then again flux linkage is maximum but opposite in direction. So for the 4 moments, you may do a step but show it fundamental component, right? So case 1 we are here, case 2 we are here, case 3 we are here, case 4 we are here. See here, this is case 1, case 2, case 3, case 4. See here, case 1 no flux linkage, EMF induced is 0. Case 2 maximum flux density, linkage to the coil, so maximum EMF. Case 3 0. Case 4 though negative but magnitude is maximum. In between case 1 and case 2, these 2 moments are there, right? Flux linkage starts from 0 to some maximum value in between, so corresponding flux linkage will induce EMFs of similar amount, varying amount, like this. So this way in phase A we can say that a sinusoidal EMF is induced as rotor rotates from, we have talked about one complete rotation, right? So similar rotation will create similar cycles in, suppose phase A, we have discussed phase A. The same can be understood for phase B and phase C, and 3-phase EMFs are balanced in nature, as we can see that the alignment of the slots are in such a way that this is forming balanced winding and rotor is being rotated at constant speed. So we have 3-phase such balanced EMFs in the 3 phases of the stator winding. So for this moment, corresponding to moment, this is N, right, 2. So this picture shows moment 2, this. So at this moment, dot is here, cross is here, how we have discussed in the starting of the lecture. Similarly, applying the same FBI, we can see that FBI here also dot will be there, here also dot will be there. Now F, because here also F is upward, motion is this, upward motion is this, though extent will be lesser. But what about this, what about this, what about this? See, F is this way now, so here also this way, right? F, where is B? Yeah, this is B, right, this is F. But here F is changed, that's why dot is there. So here also we will see cross, here we will see cross. For this moment, moment 2, let us take moment 2. So far we have discussed that as rotor is being rotated, the flux density distribution in the air gap also rotates at the same speed, that is synchronous speed. These rotating fluxes link with the stator conductors, hence EMFs are induced in the stator windings. If load is connected, then 3-phase stator currents will flow. If load is not connected, then these currents will be 0, though EMF will be induced but current will be 0. Suppose load is connected, then currents will be there. As discussed that three EMFs generated in the three phases of stator windings are balanced in nature, all sinusoidal and balanced in nature, near to sinusoidal, balanced in nature. So, the three currents in the three phases will be balanced in nature because the three EMFs generated are balanced, hence the corresponding currents will be balanced in nature. Now, we have three phase balanced current flowing in the three phase balanced winding IA, IB, IC when once load is connected. These armature currents, three phase balanced armature currents will produce a rotating magnetic field as discussed in case of induction motor. We know it very well how rotating magnetic field is produced, that is a separate topic. Then we have two fields in air gap. One field is rotor field rotating at the speed of rotor, that is synchronous speed, in any direction. For time being we have considered anti-clockwise direction. Because of that blah 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 EMFs are induced and currents are there, we have discussed, no need to repeat again. Then again another field, a stator field or armature field, rotating with the same speed at that of the rotor, that is synchronous speed, in same direction. So, we have two fields now once load is connected. If load is not connected, then we have only one field, rotor field, rotating at synchronous speed in the direction of rotor. But once load is connected, we have another field, armature field, rotating at same speed in the air gap in the same direction. Now, interaction of two fields will be there obviously. Once two fields are there in the air gap, these two fields will interact each other. So, the effect of this armature field on the main field is important to study, and this effect is known as armature reaction. In another words, we can say that effect of armature flux on main field flux is known as armature reaction. This is not so simple, as the nature of currents depends on the nature of load. If purely resistive load is there, so currents will have same phase angle as that of the EMFs generated, that is power factor will be unity. But if lagging power factor load is there, these currents will lag. If leading power factor load is there, these currents will lead. So, depending upon various power factors, this effect, that is armature reaction, effect of armature flux on main field flux, will be studied separately, and we will say how this rotating armature flux interacts with the rotating main field flux in the various cases of different power factors. Hope it is clear to you. Now, before starting armature reaction, let us discuss, or rather say recall, concept of phasor. So, everyone might have studied in first year of your graduation phasor diagram, concept of phasor. So, quickly we will brush up our concept, what does it mean by phasor. So, phasors are rotating vectors, right. So, let us take one circular path and one axis, let us say one horizontal axis, one vertical axis. So, let us take any phasor, phasor A, let us say phasor A, making an angle of theta with horizontal line. What does it mean? It means if we will plot the vertical projection of phasor, vertical projection means, see, this is phasor making angle theta. So, this will be horizontal projection and this will be vertical projection. So, remember, vertical projection of phasor gives instantaneous value. means at this point value is this. At this point, let us say this is 0, this is our reference starting from here. So, starting from here, this phasor is lying along this position, right, horizontal position. So, what will be vertical projection? 0. After this, at this moment, vertical projection is this. When it has reached to this position, suppose this position, what will be vertical projection? This. So, instantaneous value in quarter 1 increases from 0 to some maximum value. Then again after this, what will be vertical projection? This will be vertical projection corresponding, this will be the magnitude, instantaneous value. So again it rotates, reaches here, so magnitude becomes 0. Again it comes somewhere here, suppose somewhere here. So what will be vertical projection? This corresponding to this. Again it attains a maximum magnitude in negative direction, so we will reach till here. And finally, once it reaches to its original starting position, so we will reach till here, and we will say one cycle is completed, and here also one cycle is completed. So I think you all are aware of this concept, right? Thing is that vertical projection of any phasor gives its instantaneous value, right. So corresponding to one cycle is generated, corresponding to two cycles, such cycle will be generated. So while discussing armature reaction, keep in mind this concept. As we discussed that, let us take example of any phase. Let us say phase 1, phase A. At this moment, when alignment of rotor is like this, the instantaneous value of EMF induced in this phase is maximum, as discussed earlier, right? Once it will reach this position, then at that moment EMF induced, instantaneous value of EMF induced in this phase will be maximum, but not in this phase, lesser than maximum, right, in this phase. Again it will reach here is this position, at that time magnitude of EMF in this phase will be maximum, and so on, right. If we are going to draw the three phases EMFs, so phase A, right, let us draw for phase B. So for phase B, this will be maximum, right. So leave 2, right. Let us take another difference of 1, 2, right, 1, 2, 3, 1, 2, 3. So 1, 2, something like that. So see, all the phases are not attaining maximum value at the same time. Once phase A, suppose this is phase A, this is phase B, this is phase C. So you can observe from here, the moment as shown, when phase A is attaining maximum EMF, at the same time B is attaining negative potential. How? See, this is B dash. As we discussed in our convention, dot will be having positive potential, so negative potential will be represented by cross. So once dot is there in A and cross is A dash, it means we are in upper half, positive side, because A is having dot, dash is having cross. But here see, dash is having dot, it means potential of phase B is towards negative side. See, we can observe from here. Similarly, C dash is having dot, so potential in phase C is towards negative half. See here, C, at this moment this is also negative. So this way, once this rotor rotates and links with the various conductors of the three phases, the three phase balance EMFs are induced like this. Now come to this moment when alignment of rotor is like this. So instantaneous value of EMF in phase A is maximum, I think no doubt. So how to represent that? With the help of phasor? Vertical line. Maximum is vertical line. So this will be EA. Hope no doubt. Why EA? The moment when rotor alignment is like this, EMF induced in A is maximum. What about B and C? See, after A, which one is going to attain maximum? B. Once this will reach here, this will be changed to dot and EMF will be maximum. So our rotation is anti-clockwise. So after that, B will be there. As phasors are rotating vectors, rotating in this direction, so EB. The phasor which reaches vertical position will show the EMF's instantaneous value of EMF induced to be maximum. And what about C? This, we will check it again. EC. And we know that phase angle between these two phasors, consecutive phasors, are 120, 120, 120. Three phase balance EMFs are induced. So we have drawn this phasor diagram for this moment only. Fine. At this moment, this is having positive polarity and maximum value. That's why vertically aligned. This is having negative polarity. See here, EB, dot is in B dash. Once dots are there in the dashes, means negative polarity. When dots are there in or cross are there in dashes, it means positive polarity. Okay. Now let us take any power factor load, starting from unity power factor load, purely R load, right? So case 1 right here, unity power factor load, UPF, unity power factor, or write full. Case 1, case 1, unity power factor load, that is purely resistive load. Purely resistive load. So in unity power factor load, the three phase currents will be in the same phase of corresponding phase EMFs. If you want to draw, so this will be your IA. Depending upon the magnitude of load, let us take any magnitude, not necessarily lesser or maximum. I am not going to compare, but different phasor, but in same phase. Main thing is that IA will be in phase of EA in case of unity power factor load, purely resistive load. Similarly, IB will be in phase of EB and IC will be in phase of EC in this case. As discussed earlier, when current in a particular phase is 0, corresponding flux is 0, in aligned along its own axis. If IA is maximum, corresponding flux will be maximum, means flux will oscillate along its own axis. See, stator is stationary, so axis will be fixed. So phi A will oscillate, sometimes 0, sometimes maximum, sometimes minimum, and it will oscillate. Similarly for phi B, it will oscillate, phi C, it will oscillate. So if we want to see the amount of fluxes in the three phases at this moment, means at this moment when rotor is aligned along this. So what will be IA? Let us write instantaneous values first. So IA will be, IA is along this, so IA will be, vertical projection will be IM. So right here. What about IB? So IB will be, let us take vertical projection. So this is 90, this is 30, so this will be 60 degree. find. So vertical projection of IB will be, see this is negative, so with negative sign we will have minus IM cosine of what is angle? Projection, we are taking cosine angle, right? 60 degree. So this will be cosine 60 means sine 30 half minus IM by 2. What about IC? IC will be vertical projection of this phasor. So what is angle between these two? See, complete angle is 180, right? Linear pair. This angle plus this angle will be linear pair. So this is 120. So this will be 60. Again 60. So we will write minus sign because this is downward. See, this is positive direction of y-axis and this is origin. This is negative direction of y-axis. This is positive direction of x-axis. This is negative direction of x-axis. So this will be again minus Im cosine of 60 degree, that is having same magnitude Im by 2. You might have observed in our wave shape of 3 phases, right? So one is crossing here, right? At this moment both were crossing, B and C both were crossing. It means having negative sign with same magnitude because crossing was there, right? So that's why we are getting same magnitude. What about fluxes? Once IA is having maximum value Im in phase A, phi will have maximum value phi m. Once current is 0, flux is 0. When current is half, 50%, flux will be half 50% of maximum value. So once current is maximum, so directly we may write phi A, flux, armature flux of phase A, maximum. So let us denote maximum value of flux by phi m. As we have denoted maximum value of current as Im. So what about phi B? This will be, phi B will be minus phi m by 2. And similarly phi C will be minus phi m by 2. Now put the corresponding values in this diagram to get the resultant one. So I am making here. So at this moment we have this phasor diagram. For unity power factor, currents are in corresponding phases of EMFs, and we have at this moment fluxes in the 3 phases, fluxes produced by 3 phase currents as maximum, half of maximum in negative direction and this. So phi A, so this is positive of phi A